Progress. I'm gonna have a heart attack if they change that electronic voice or the message. It'd be funny for you all. You just watch me clock. I just get up and leave. There's a defibrillator somewhere in this building. By the time you find it, I'll be croaked. And I'm not advocating that you do that to me, but it'll be funny for you all. All right, let me go ahead and find some files. That might take me a while. Where do I want to do these experiments? I think I want to do it on my home server. The reason I want to do it there is if I do what I would call the, oh good, there's at least a attempted rubric. If I do it with what would be a fairly, call it naive, but nonetheless correct approach to stealing the money out of the accounts, it takes it 4 or 5 minutes to run the whole thing. I don't want to do that on the Amazon Web Services server because I actually don't want to pay for the clock time. Let me go ahead and get a go to the playground, and we'll do everything in Friday the 13th. Yikes. So all I'm doing now is I'm creating a workspace so that we can experiment with the problem, the example problem. We're going to start with the one from the exam as is, and then if I can find it, I will modify that for how it was supposed to be, but it was determined that it would have been too hard for you to do it the way it was supposed to be, which is ironic because the way that it was presented, you didn't even need NumPy the way it was supposed to be. So the original way, the accounts were randomized. Some of them had $100 in them, some of them had $100,000 in them, and so forth. And in that case, you actually need a computer program to figure out how much money you can steal. Now, why would us as electronic thieves care about predicting how much money we can steal? So I want you to think like evil criminals. I want you to get your criminal mind out. Everyone has one. Most of us suppress it, which is the right thing to do. So to go ahead and steal money, you need somebody to finance you to pay for all the widgets and shit that you need to hook up at the bank to steal the money. So where do you go to get money like that? You can't go to the Small Business Administration and get a loan. Although they do loan money for people to steal money, but in much more legal fashion. So your only recourse at that point is loan sharks. Okay, so that's what I was after, the mafia, either the US mafia or the Russian mafia. Currently, the Russian mafia is not a good source of criminal financing because they're temporarily locked out of the international money transfer system, unless you're willing to accept payment in oil tankers with Russian flag registrations. Sorry, Vladimir, I was not really making fun of you. It just it just fits for the story. Okay, so we need to go ahead and get some financing, steal money from these 900,000 accounts. So you want to be able to tell the people that are financing you about how much money you're going to make. And you kind of need to be accurate on that. Why do you need to be fairly accurate on it? What does the mafia have a tendency to do if you can't actually pay back the note? Oh, that's only if they're really mad. Next lesser is they break your legs. So you're going to be running around in crutches in a wheelchair, all because you didn't pay attention in ENGR-1330 on how to steal money electronically. So let's go ahead and try to do it right. Okay, so I think that was the problem statement. 900,000 bank accounts. We were even told the interest rate, and we're told the interest is added to the balance of each account with the exception of fractions of a cent. So imagine an account in decimal dollars, 1.0129. So there's $1, 1 cent, and then 0.29 cents, or $0.0029, which would be 29 mils. So we're taking all the mils, and the way banks make their money, in addition to just flat out cheating, is this is what they do institutionally. They take the mils and they put it into a bucket somewhere. And then at the end of the day, when they reconcile accounts, they look in the bucket, hey, look, we got $3 million here. Cool, already. And they do that every single day of the year. So what we're going to do is intercept that legitimate banking activity, legitimate in the sense that it's allowed legally. That banking activity, we're going to intercept that, putting it into the bucket. We're just going to take it all for ourselves. So we're going to name our bucket. We're going to name our bucket Bitcoin. So that's where our bucket Bitcoin comes from. Okay, is everybody ready to be a criminal for at least a little while? Again, since I'm being recorded, I'm not advocating criminal behavior as a future line of work for a couple of reasons. The pay is really good unless you get caught. And then you have to pay in a different way, which is decidedly unpleasant. So let me copy this. So first we're going to create the accounts. There's no brains required in this part, as most of you have experienced. Let's go to the playground. Where's Friday the 13th? That was actually a really bad movie. Okay, so all I'm going to do is create accounts here. So let's create these accounts. And good. So we have accounts. We have accounts in an object name because we have no creativity in naming. Let's take a look at, say, the first 10 entries of accounts. Anyone remember how to do that? Either a hard way or an easy way? It's not a data frame, so we can't actually just use a head. But it is an array, which means it's indexable. So how do we slice the first 10 things of an array? I think we go 0:11. And we don't care if we get the first 11 things. We just want to look at the top end of the front end of the array. 0:11. Hit return. Oh, that's kind of interesting. Each account is identical. So if during the exam you had immediately recognized that and say, oh, well, I can do this in real easy and simplistic, almost asinine hack, figure out the behavior for one account and then multiply the result by 900,000, and I've done it for every account. We'll save that for later. Let's pretend that we're not that bright. After all, we are criminals. My good friend who recently retired, actually a few years ago, from the California Highway Patrol, he was one level below the director, spent most latter part of his career keeping governors from killing themselves by making bad decisions, which apparently is hard to do. He says if it wasn't for criminals on the average being stupid, we would never catch anybody. So again, that's why as engineers, you already have a slight edge there, should you choose a life of crime. The fact you're actually here means you're already smarter than the average criminal, at least the average criminal that gets caught. Now, who are the best criminals in the United States? No, the best ones. He's certainly a good fictional character, but the best real one. For example, you see them on TV every day on CNN, CNBC, Fox News. Those are the best ones because they get away with it by making what they do legal. It is getting to be tax time, so I'm going to be kind of cranky, and at least until after that's done with. I apologize in advance if that bothers you, but one of my advantages of the bully pulpit here is I can influence your minds so that you hate paying taxes too, and in years from now, maybe you'll find another way to finance our country. Invading a neighbor is not a good idea. Okay, so we've set up our accounts array. Let's read the next part of the problem, wherever I put it. Oh, somebody gave us a code to add interest, and they actually gave us some background. It says daily interest is simply the product of daily compounding rate and the account value. So if we didn't want to use the add interest function, we wouldn't have to. We could create our own. In the whole scheme of things, it's not a very difficult equation. Take what's in the account, multiply by the interest, segregate that into the part that gets to go back in the account and the part we're going to steal. Put the part that goes back into the account, put the part that we steal into our bucket named Bitcoin. We're done. But let's just use the function. So we'll grab the function, go back to Friday the 13th. Hopefully I have all the packages it needs. Okay, so the function's been prototyped. Essentially what I did is ran it. There's now an object in my kernel named add interest. It's expecting two inputs. One input is a value, the other input is a rate. And you can tell that kind of just by looking at the code. You don't have to figure out what it actually does. But it looks like it takes as input current value and a daily rate, and it returns as output whole dollar amount plus pennies and the skim amount, the stuff that we're going to keep into our bucket name Bitcoin. And then it returns the output. Oh, and look at this interesting comment. This was key to understanding how to actually use that function. It says it returns a tuple. When we mentioned functions and tuples, that was mentioned off the internet already. Excuse me. Refactoring internet provided code for your homework assignments, which is acceptable as long as you cite it. You would have discovered this at some point along the way, because that's how most of the functions that are provided to you in various blogs are structured if they're returning multiple outputs. Usually the output is put into a tuple, or you could put it into a list, but that actually is prone to a whole bunch of other errors. Okay, so now we have this function. So since we're doing simulation, which is actually the official topic of today's lesson, it's in our best interest. Let's just try this on one account for one increment so that we can learn how to access the function. So what do you want to name this? I like to name stuff junk. God, word has such another naughty meaning. What's something trash? Okay, damn language changes every 2 weeks. You can't keep that. So we're going to name an object trash, and into trash we're going to just go ahead and run the add interest function. Let's just put a value of 100, and let's put a interest rate of 10%. Obviously nothing to do with our accounts or anything yet. This is just to see how the add interest function works. So our understanding of what add interest would do is it would take 100, it would multiply by 0.1, and it would get a value of 101. No, it would get a value of 1. 10. 0.1 of 100 is 10. So it would tell us that the compounding amount would come out to be 10, and then it would split the whole dollar into pennies and sub pennies. I picked numbers that are exact so that the nil fraction is going to be what? There'll be nothing to skim in this particular instance, I think. So let's run the function. Cool, we ran the function. Now let's look at the contents of trash. Let's go through our trash. Oh, that actually was a pretty good fun. Okay, so sure enough, trash is a tuple. It has a whole dollar amount of 10 and a part dollar amount of 0. So let's rerun it, but let's get a case where we'll get a weird. So I've changed the interest rate in hopes that I can get something I can steal with. So you notice how all banks always discuss two interest rates, you know, our nominal rate is, and our annual percentage rate is, and the actual amount of your money we steal, we're not telling you. You have to just figure it out. It's some average between the two. So let's say we get, actually, let's be even a little bit sneakier. Rounded to one decimal place, that's 10%. So if I were a bank, that would be how I would advertise. We offer 10% interest. And then in small print, really small print, probably in a font that doesn't make sense if you blow it up, the actual interest rate is 0.9999 rounded to one decimal place. So let's run our trash again. Let's go through the trash again. Aha. Okay, so we get $9.99 back, which is what we anticipated. And there is a non-zero value in the skim bucket. So that's how this particular function works. Now, how do you get individual pieces out of the trash? How do I get the whole dollars out of the trash? Yeah, a tuple is indexable, so you could do that. We should get $9.99 back, and we can do that. We get the 2 parts in 10 to the minus 16th dollars back, which is not very much money. But you multiply that by 900,000, you do that a few days in a row, and pretty soon that adds up to real money. And that's basically how you run a government of a major nation. Okay, so it looks like we have diagnosed how the system works. Let's go ahead and do a single day. And we'll do it the naive way. So how many accounts do we have? What's the name of the array? So we're now starting to construct a count controlled repetition loop. And I is going to represent a particular account. We're going to run through all 900,000 accounts, get the interest, add it back into the account, get the skim, drop it into our Bitcoin bucket. So what's the easiest way to add the interest into any individual account? Okay, so in any individual account, it's whatever was there plus what? We take whatever's there, we're going to add in something, and then put the result back into accounts. So we'll just plus add interest. I have to tell it what to add. We take what's in the current account, and we need an interest rate, which was 5 over 365 over 100. This is actually very bad programming here, because I should actually compute that constant prior to accessing the function, because it now has to do arithmetic before it can actually execute the function. Okay, if we just stop right there, it'll do something. It'll probably run without throwing an error message, but we'll have no idea what's going into the accounts. What we want to add in is what part? The 0 part. Skim, no, Bitcoin. Equals whatever's in the bucket. Since we're thieves, we don't assign any particular value to a particular chunk of money. We don't care where it comes from, as long as it ends up in our bucket, so we can take it home, give the portion to the mafia to keep from getting our legs broken. And then of course they'll increase their rate. Says, oh yeah, we lied. We need twice as much. And if you sell us the program, we'll just take it all. And if you don't sell us the program, we'll break your legs. That's an easy decision to make. So, okay, so we take what's in Bitcoin, and what are we going to add to it? We want to take what came out of that but we want to get the skim portion. And I think that will work, but let's find out by getting to the right. Come on, machine. Ta-da. This is for a single day. And when we're done, what do we want to report? Yeah, let's okay, so that will probably work. Let's modify our range temporarily. Let's just do one account so that we can kind of look at the output and see if it makes sense. In fact, we should do one account in trash. So what would be the one and only account? Anybody? Let's start at 0. And the interest, we'll just do the 5/365/100. And then we want to look through our trash. Yeah, I saw that computer screen. I'm not actually showing them how to steal money, so come on, look, there you go. Okay, so there's our trash. In this case, we round it up, we get a whole penny, which is actually kind of impressive. And 0.00386 dollars from one account one day. So now let's go ahead and run our simulator for one account one day. What output do you expect for the we stole Bitcoin amount? I expect 0.00386671 blah blah blah. If we don't get that, we have an error. Bitcoin is not defined. My bad. So where should we put Bitcoin? Someone from the back row that's still awake, what value should I assign to Bitcoin? So I got a big 0. I agree. So now we are creating Bitcoin. We're starting with an empty bucket because, okay, so we stole 0.0386986, a slight difference. I actually don't know why that is. I suspect it probably has something to do with how accounts is represented in the listing structure. Zero, 5. All right, well, we'll go with that. I would say that's close enough. So now how do we do all the accounts? Length of accounts. And gee, it's taken an awful long time. What could be going wrong? It's accessing a very poorly written function 1.6 million times. So the smarter way to do this function would be to actually just assign it to an object and pull from the object, because then you only have to run the function 900,000 times. But we're done, and we come up with $3,481. That's not bad for a day's work. I mean, how long did we spend doing this work? Oh, about 20 minutes. I mean, that's pretty good take. I could retire on that. I dare say any of you could retire on that. You'd be healthy, and then you could like start branching out to other banks. That's why they call them branch banks anyway. That was just one day, but what was the actual problem?
110 and 100.
Okay, so let's just do for days less than equal to 100. We need to start with days. That's actually not the right loop structure. While, and whether you choose a while loop or for loop is up to you. The other way would just to do a for loop counting days. So while it's less than 100, what I want to do, I want to days, add a day to days. Then I want to go ahead and compute the amount of Bitcoin. And then because we're lazy, we want to print the amount at the particular days. So let's take our print function, copy it, move it up into here, get it into the right place. That's indexed is incorrectly as of right now, but we'll fix that in a second. If, we'd say 110 and 100. If that's true, I am suffering under different coding structures, so bear with me when I do characters that don't make sense. So if days equals 1, what do we want to do? We want to print how much we stole. We stole blah, blah in what's the other conditional? Gee, I'm not having to do much thinking now. I'm having to use the miracle of cut and paste, which was the intent. If nothing else comes out of this, I mean, other than you hate me, which is fine. Not really a popularity contest. That's, if nothing comes out of that, if you get comfortable with cutting and pasting and taking stuff off the internet, figuring out how it works and then making it do what you want, we've won. The goal of the class is accomplished. And if you're really lucky, you don't have to retake the class. That's even better for everybody. I don't think anybody's at risk of that. Just got to go ahead and say it because I'm on recorder. Do that one more time. There's actually the, I guess I could run the time function to see how long it's taking to do each of those, but there's no point. So to get to 100 is probably going to take the remaining time in the scheduled lecture today. So this is clearly not the only way to do this problem, but this is what I would call the most naive way to approach it. It's simply working with arrays, working with functions, getting one thing at a time and just throwing it into a bucket. There are probably more efficient ways, and I'll describe to you, if I can actually find the code, I'll show you the way the problem was originally set up. And okay, we can comment that off, and hopefully I've got everything. So semicolon, that stays in the, I think I've got that structured right, and we'll know in a second. Now, because it's going to take a long time, if I seem to lose control, what do I do to my computer? You go ahead and I'll interrupt the kernel, hopefully regain control. All right. Anybody see any glaring errors? Given that no one knows what I'm doing, I'm going to guess not. So shall we let her rip? Let's just do 1 day since we know the answer. Mostly, I want to be sure that the writing structure is correct. 1 day, we know we should have an answer back in a few seconds. Okay, so same answer as before. Go for the whole 100 or just 10? Whole 100 it is. And we will let it run. So on your computers, on your laptops, it's going to run considerably faster than a Raspberry Pi computer duct taped to the back of the television set.
in my living room. Yeah, I don't think anyone's got a home built laptop here. If you did, you would have to be sitting in the rows to get electricity. You can build a really cool laptop out of a Raspberry Pi if you want to. The problem is batteries. They're energy hogs, and the little, like a 2400 milliamp hour lithium ion battery, it'll idle for almost a day, but once you actually start running stuff, it burns through the battery real fast. Sub 40 minutes. Okay, so we got through our first day. That's not enough to have a really good party yet. So let's go for the rest of the week. How about we can realistically predict what we'll have at the end of 10 days, $35,000, give or take a few bucks. And since it's stolen, the give or take is kind of not a big deal. $35,000 bucks, we can have a pretty good night at the bar. Everybody will be okay. So it's going to print 35,000 when it gets to 100, about 350,000.
So I'll just let it run in the background. The other way to have solved this particular problem would have been to just do one account, because the accounts are identical. So the interest is going to be identical every time. And multiply the result by 900,000, because that's how many accounts we have to work with. That takes a fraction of a second. Yes, sir.
Would you need to reset the accounts every time you run it? Because currently, each time you run it, the numbers are changing a little bit.
Yeah, that's how you get people to deposit money in your bank.
Well, it is, but if you're trying to run just the day one value, you need to reset it so that you get the one per day one value.
No, we're letting the owner accounts accumulate money, because that's what we have a contract with. We're letting our account steal that incremental part every time the daily compound is computed.
What I'm saying is, if you run it in one day, that number 3,455 is going to increase a little bit, even though you're just running the first day. So would you want us to reset it?
Well, everything starts at 0 every time we run it.
The accounts doesn't, because you haven't set something to 0.
Oh, I see what you're saying. Yeah, we would have to rebuild the accounts each run. You're correct.
I misunderstood your question. So now we got 35,000. I'm going to go ahead and terminate it. I'm sure if it can do 2, it should be able to do the third one. Okay, let's see. How do I terminate? Kernel interrupt. Ooh, I was in the process of calculating pennies at the time I sent the interrupt. Okay, so that was one way to do it. Now the original problem was that the NumPy array was not going to be all the same value. It was actually going to be random numbers between 100 and $100,000. Once that happens, if that array was no longer identical, you would be obligated to do a methodology where you have to process every single account. And that's what banks do. That's why when you go ahead and assume you all have an employee location device, I guess a student location device right now, but sometimes today it's employee located device. When you log on to your bank account, say you run your credit card, they're really fast at scheduling a transaction. So what do they call it? Temporary authorization. And you're like wondering, why does it take them 3 days to go ahead and actually pull the money out of my account to pay the credit card? It's exactly this. Banks can't make a living on just 35 customers. They have millions of customers. Who has Wells Fargo? You are in conjunction with about 350 million other customers. Bank of America, roughly the same. Credit unions are quite a bit smaller. They're like in the hundreds of thousands of customers. And their scripts don't take any shortcuts. They actually have accounting reasons that they have to do it this very slow way. So that's why it takes a seemingly long time for them to reconcile. American Express can do it overnight. So that's probably pretty typical of most
banking and major money institutions, they can accomplish this overnight. I find it hard that the university takes 3 months to accomplish the same task, but we're not as smart as people in banking. So what we did that's relevant, and I know I'm cutting into your lab time, sorry, is, oh, actually, there's another class in here. What it did, this was simulation. This is what computational thinking is all about. It's being able to simulate behavior in order to answer questions about it. All right, go free. We have another class in here and they're probably angry at me now. Thank you for your attention. I'll see you Friday if I'm lucky.
So we'll go through